The mysteries of Sasquatch.
Discerning truth by examining mysterious phenomenon using logical reasoning.
The Presumptive Assumption. Every creature that exists now on Earth would be recorded in the fossil record, especially any bipedal hominids. This is the presumptive assumption. There is no biological theory that states this. If there was, it would likely be wrong. This is a basic misconception that complicates the issue of their existence. We start by examining the evidence gathered from the fossil record. To prove the rareness of fossils, we can use the Fossil Rarity Quotient. The first equation is the general form of which examines the number of fossils found per animal. The species here are limited to the animal kingdom of the phylum Chordata, the vertebrates, since they leave fossilized bones. Very rarely, animal remains can also be preserved by being frozen, caught in tar or amber, mummified or petrified. But here we are looking only at fossils that usually form in sedimentary rock. The Fossil Rarity Quotient compares the total number of all fossils found, X, divided by Y, the number of all animals that have ever existed, shown as Z equals X divided by Y. This ratio shows us how likely it is that any one animal that has existed will leave a fossil in the fossil record. The dividend X can be broken into X1 and X2. First, the fossil has to be created, then it has to be found and confirmed by a paleontologist or anthropologist. So let's rewrite the formula using X equals X1 and W equals X2. X, the creation of a fossil bone. W, the percent of Earth's sedimentary deposits excavated for fossils. So, X equals number of fossils created per Y equals number of animals that have existed. W equals Earth percent successfully searched. Z equals X divided by Y, times the W percentage. This multiplies the ratio of fossils created per animal by the percent of Earth's sedimentary deposits that science has successfully searched. Let's say the odds of any one animal leaving a fossil is 1 in a trillion and the percentage of Earth's sedimentary deposits that has been excavated is 1 in 100 million. W equals 0.000001%. X over Y equals 1 divided by a trillion. Using the Fossil Rarity Quotient, the odds of one animal being found is projected at 1 in a 100 quintillion. 100 million times 1 trillion. By estimating the rarity, it can also be used to calculate the number of animals that have ever existed, as the number of fossils, X, times percent of a area, W, divided by the rarity ratio Z. The Special Fossil Rarity Quotient. The second application of the equation examines the number of fossils found for each animal in a species. X sub s equals number of fossils created by a species. Y sub s equals number of animals in the species. W equals percentage of Earth examined. Z equals X sub s divided by Y sub s times the W percent. This gives the likelihood of an animal of a single species being fossilized and found, thus providing evidence for identification of the given species in the fossil record. Each of Earth's 8.7 million species will have unique X-dividends depending on habitat and life cycles, and Y divisors depending on the animal's population. Species who inhabit arboreal forests or high mountain plateaus have a very low likelihood of leaving fossilized bones. Fossil bones are mainly found in sedimentary rock formed in marine basins. For example, despite their abundant presence, chimpanzees' fossils were not discovered until recently. This is true with other monkeys, apes and other arboreal creatures. Conclusion.
The Fossil Rarity Quotient demonstrates to us that there are two extraordinarily rare things that need to happen to create a fossil for the fossil record. The bone has to be fossilized and the fossil has to be discovered. The fossil record is just a scratch on the surface as to what has existed in the past. The minuscularity of the fossil evidence should be recognized by anthropologists. There is no reason for us to presume that because we don't currently have bones or a body, that Sasquatch does not exist. In fact, there is cataloged in the fossil record a great ape in Asia known as Gigantopithecus, presumed extinct between 100,000 to 10 million years ago. A primate similar to this still may roam the earth, known today as Sasquatch.